Good morning and welcome to this webinar this morning. I'm David Greenfield. I'm going to be your chair for today. I'll do a few little introductions, give you an overview of what the session is going to be about, and introduce you to our brilliant panelists. So today we are talking essentially around unlocking waste management potential with AI. And we've got three brilliant speakers: Conor McGooey from Regen Group, who's the CIO, Steve Ullman, who's head of partnerships at Greyparrot, and Luke Mallinger, who's CEO at SortFlow. Each of them are going to give a little bit of an introduction to what they do, why they do it, and the impact it has for the waste management and resource management sector. I'm going to give you a little bit of an introduction to two aspects: composition of waste over the centuries and what circular economy is, and how that's an absolutely relevant topic for today. We're then going to go into Q&A, and at that point we'll also invite questions from the audience. So hopefully you're here at the right event, and this is very much about thought leadership. We want to get people thinking about the future and understanding the opportunities for AI and advanced technologies. So I'd like to start by giving you a little bit of a backward look in terms of waste management and what's been happening over the centuries. So if we can have the first slide, please. For those of you that are interested, this is what the composition of waste has been in the UK since the 19th century. The big blue bar at the beginning of the graph is essentially dust and cinders, which gives rise to the term dust man, dust cart, dust bin, because essentially everybody used to burn everything at home. As you can see over the next few decades, that composition has actually dropped quite significantly, has been replaced by lots of other waste materials: paper, plastic, food waste, and more complex materials, to the extent that by the end of the 20th century, we were looking at very small amounts of dust in the waste stream. Interestingly, that's gone up slightly because of home hearth and the propensity for people to have a nice log burner at home, but it's nowhere near the sort of material that it was previously. What that means is that when we're talking about recycling and capturing recovery, we have a much more complex material stream than we did 150 years ago. And one of the main challenges is, how do we actually capture that material to ensure it can be given a second life, either through reuse or through recycling? So today, that's one of the elements of what we're going to be discussing. How can we use new technologies to ensure that we're capturing as much of this valuable resource that is in the waste stream that we possibly can? And if we can have the next slide. The circular economy is one of the solutions. It's a term that has been used very well over the last 13 years, since the Ellen MacArthur Foundation essentially coined it as a term. And it fits very nicely into new business models. So this is from the OECD, and there's various different versions of this. But the 5 business models which really power the circular economy are the circular supplies, so moving to renewables and bio-based materials; resource recovery, which essentially is what we're going to be speaking about today. How can we capture resources that are already in the system and recover them to the highest possible value? Product life extension, extending life of various different things, sharing, what items, what services, what people can be shared to promote circularity, and then products as a service. How can we actually get the outcomes that we want without potentially having to capitalize them through purchase? And 3 of the disruptive technologies that will support that are listed in this box. I'm not going to talk about physical technologies or biological technologies. You'll all know what they are, but today is very much about digital technologies. So the digital technologies that are going to power the circular economy and power the resource recovery that we need of the waste streams that are currently being thrown out on a daily basis by the general population and the businesses that we work in. So hopefully that's been a little bit of an introduction from my perspective in terms of why we should be talking about AI as an enabler of resource recovery. Now I'm going to pass over to our three speakers and get them to give a little bit more in depth of what they're doing and why. And we're starting with Connor McGooey from Regen. Connor is a highly acclaimed Chief Information Officer with over 20 years experience in IT systems analysis, development and administration across diverse sectors. Connor, you're very welcome, and we look forward to hearing what you and Regen are up to.
Thanks very much, David. So Regen began around 2004, started by three brothers who were all engineers. And that engineering mindset and led the guys to say, how do people currently do stuff? And are there any ways that we could do that any better? And I would say that nearly 20 years later, that mindset persists. So absolutely everything in this place is up for grabs in terms of how we do stuff, how we process things, how we look at AI, how we look at anything. So there's nothing ever off the table. A good idea will be, they're always welcome no matter where they come from and judged on their merits. So that mindset is what allowed the guys to build a MRF that scaled to doing, I think at recent count it was over 200,000 tons per year. So all the time we have the scope, the encouragement, the financial support to do proof of concepts for things. There is an appetite for risk about maybe sometimes slightly unproven business cases, because we always feel that being slightly ahead of the curve is the place to be, because if something doesn't happen with you, it happens to you. So everybody is very excited about the possibilities of AI and turning them into actual actionable decision points that giving people data that will help them do something differently, sell something better, or perform better. So we firmly believe that well invested in, well-designed MRFs can take commingled materials at huge scale and produce great quality output. Thank you.
Thank you, Connor. That's great. Really nice to hear that your ambition is about trying to recover as much value as possible. And that's where the partnership that yourselves have embarked on with Greyparrot and SortFlow is really interesting. So let's pass over to Steve Armand, who's head of partnerships at Greyparrot. Steve has more than 25 years experience in the waste and recycling sector and is an expert and thought leader in recycling processes, specializing in MRFs. Steve, and please do remember, if you have got slides, to ask for the next slide.
Thank you for the intro, David. Yeah, welcome everybody to the webinar, and hopefully you'll find this an informative debate. Before we go into the main details, I just want to do a very brief introduction to Greyparrot and the product. And you can hopefully see here from this slide here that we're offering a straightforward camera system which harnesses computer vision to enable us to analyze waste materials in a continuous flow on belts in MRFs. So that's a summary of what we do. And of course, then we get the data, and we have the data then to give to the people, to the waste companies. So the background, we've been going over 4 years now, and I think the first couple of years we were more behind the scenes, where we were gathering billions of images and building our database, our library, if you like, of information. And you know, we deployed units right across the globe to do this. And we're currently sitting at around 70 different classifications of waste materials across the packaging domain. And that's going to increase, continuously as we develop into, more industrial processes, waste electronics and scrap metals. So you'll see this development continue. I think one key point I want to make at this early juncture is about one key feature is that, our accurate analysis of waste materials has been focusing on, the items, but more importantly for the MRF industry, we're able to convert that item analysis to weight or mass. And this is the really big thing we're able to do to a very, very successful levels with in excess of over 95% accuracy. So we can maybe, I can answer questions on that later, but that's a very important point when it comes to analytics in recycling plants. So more recently, we've been commercial, and we've got around 35 people now supporting that function. And we're working with probably most of the global waste management players who are processing 70% plus of global waste arising. So we're really getting a lot of experience already. The last part of it is the dashboard. You can just see a quick glimpse of that. This is constantly being updated to give the customers exactly what they need in a very nice visual format with pie charts and nice colors. We're just launching a new alerts dashboard, which is enabling us to really get to grips with different materials and looking at flow changes in plants. So lots of exciting things to come. And on to the next slide, please. So this takes me on to the last part of the product. And this is what we call our APIs, or application programming interface is the official name. Those people who didn't know that. And it's really just a matter of, it's a simple thing. What it means is we can plug in to other systems, whether it be hardware or software. And you can see from this graph, we positioned ourselves in the center of the graph because we see ourselves hopefully as the brains behind the recycling plant. And our APIs can reach out to all these stakeholders. You can see here we've got some software. Luke will talk about his how he uses our data shortly. You can see Power BI there. We can take data straight out into the waste management company's own platforms. So that's all doable as well. Then you can see the other stakeholders. We've got the OEMs, all the robotics and the optical sorters and shredders and balers. We can work with these guys. And last but not least, you've got the people who actually assemble these plants. The plant builders. And we are at the position now where we can give this dynamic control to plants. We can go into SCADA systems. And if all the stakeholders on this chart all come together and work together, we can create, MRF of the future, right now. Next slide, please. And the last one, this is just a general view of our applications. We will touch upon this a little bit later, a bit more detail, but, I always associate this with chapters in a book. And if you read every chapter in a book, you understand the ending. If you miss bits out, you're not going to get a full details. And it's the same with our camera systems. The more cameras you deploy to get the right data, the better you understand the complete process. And at that point, I shall hand you back over to David. Thank you.
Thank you very much, Steve. And already started to get some questions in through the Q&A service. So please do continue to ask questions, and I'll try and pick those up as part of the Q&A. So thank you very much, Steve. That was really interesting and really good to start the conversation about the application of Greyparrot and the linkage. And of course, one of the key elements of circular economy is sharing and collaboration. So I think the point you made around bringing the whole sector together and getting the systems in place to ensure that we have that interconnectivity is absolutely critical. So let's move on to our final speaker for this morning, Luke Manager, who is CEO of SortFlow. Luke has 12 years experience in the waste and recycling industry, working and sharpening his understanding on leading technology companies in this space. His SortFlow's mission is to develop innovative software. So let's hear about the innovative software and how that can power and transform the recycling industry. Luke, over to you.
Thank you, David. So hi, I'm Luke Malinger. I'm the founder and CEO of SortFlow. So first of all, I'm very happy to be part of this webinar today. So thank you. So for those who don't know SortFlow already, I'm going to tell you a bit about the company and our mission. So we make software applications for the waste and recycling industry. When we started off in 2020, we had one objective, and that was to build a design and performance modeling tool using mass balance calculations. This is the foundation of how sorting processes are put together, sized, how expected performance is calculated. So the idea of SortFlow started when I was working for a plant builder. I was spending a lot of time doing mass balance modeling for new sorting infrastructure project. It was a very tedious process using Excel, and also quite limiting. So I really thought, the industry could really benefit from having a simpler, faster, and better tool. And so that's what we created with our SortFlow process application. This application has been live for over 2 years now. It's used by waste management companies, plant builders, consultants, and researchers. And we're updating it and improving it continuously. We're really pleased with how powerful the tool has become. And if you haven't seen it already, obviously feel free to book a demo. Next slide, please. Now we're in a very privileged position because we get to talk to a lot of different industry players, and that includes, of course, MRF operators. So what we hear from a lot of MRF operators is that their process is a bit of a black box, that they generally understand what goes in and what comes out of their process, but equipment performance, variability in throughput, composition, these are things that are very difficult to track and fully understand. And of course, the issue is, if you don't know how your process performs over time, how can you optimize it? How can you be sure you're getting the best out of it? And how do you know when you have performance or quality issues? So that really got us thinking about how we could help MRF operators solve this issue. And so for us, the next logical step was to use the foundations of our process modeling application and combine it with live plant data from intelligent systems, effectively building a digital twin application. So that's an application that can be used to monitor, understand, and optimize sorting processes. And this is what we are developing at the moment. And we're in the middle of pilot testing a digital twin tool at the UK plastic recovery facility using Greyparrot AI vision systems. And that's what leads us to having this conversation today. So again, thank you very much for inviting me.
Brilliant. Thank you very much, Luke, and really interesting insight into some of the technology. And digital twins and the waste management are probably three words that haven't been associated too much in the past. So it's really exciting to see that we are pushing the envelope in terms of technology and looking at how we can treat what is a resource stream in a much more effective way. So thank you, everybody, for doing a really short introduction. We've got a couple of questions that are already coming through. I'm going to address those a little bit later on. But I'm going to start off by asking the panel, and starting with Connor. Really, from your perspective as an operator, why and how did you decide to install and get involved with Greyparrot in the first place?
It's Greyparrot. This journey began on a webinar Joseph, our CEO, attended with Michaela, the founder. And immediately when the webinar finished, Joseph emailed me to say, made the introduction to Michaela and says, go and investigate that, please. That sounds like a great idea. So as we spoke to companies then, some of the sectoral experience that people like Steve had in Greyparrot put them slightly ahead because they understood the industry. And then that was slightly easier then because we didn't have to explain as many terms. We didn't have to tease into our motivations, like some of that knowledge came already. So those two factors.
Brilliant. And how long has that association been now?
3 years potentially, Steve. Is it nearly something like that? 2 anyway.
Yeah, for sure. And yeah, we've known each other a long time, of course, over the years with various other technologies, and trying to get to the next level. So it's been great journey.
And Steve, as you're there, I think from your perspective, why did you want to work with Regen? How did that symbiosis come together?
I think, as Connor mentioned earlier, they are a risk-taking business. They always wanted to be that next level and the next technology. And I had the same I shared the experience with them in a previous life, trying to automate the processes some years ago with optical sorters. So, and they are very keen to take the MRF automation to the next level and try things out.
And we've got a slide up now, which is giving a little bit more detail as to the process. Steve or Connor, do you want to just talk to that a little bit?
Yeah, so our initial proof of concept, we decided to put it on a paper line. So you can see there on the left, we have QC optimization, pre-QC. So that tells us what's coming out onto the paper line before the pickers, after all our other processes have happened via optical sorters, pre-picked lines, eddy currents, so on and so forth. And then just before the bunker, we have another camera, and that tells us continuously what materials get into that bunker. So that creates a lot of opportunities. It allows us to study and analyze how well pickers are performing. It allows us to say how well the material or what the composition of the material is arriving at the paper line, which tells us how well our optical sorters are doing and our other processes. And then on the outbound material, that gives us nearly a continuous quality control on the composition of the material that eventually ends up billed and sent to customers.
And I think that for me is one of the most interesting things, the fact that you've essentially got the ability to be able to look at the material outflow and go, actually, this is 95% or 99% quality. If you, how can you use the AI to intervene, or is it very much just ensuring that you've got a specification of output that is then eminently saleable because you have much better information?
Totally. So that's a continuous feedback loop to our plant managers. So we would be arming the plant manager with the information about, here's the composition of material arriving before the pickers. So we can set thresholds or alerts, or he can study the dashboard to say, there's maybe slightly too much hard plastics arriving in this line. That would allow him then to go back and adjust some of the programs on the optical sorters to make them maybe slightly more aggressive towards certain types of materials.
Brilliant, thank you. And Luke, I'm just going to bring you on this place. How do we then take that to another level, and where does the digital twin fit in?
Well, for us, obviously, with the objective of building a digital twin, we needed good data and a lot of data. So the first place we looked at was obviously, well, data that is already there available on the plant, and that's the data from optical sorters. So first we looked at, okay, can we get this data? And if you have like optical sorters that are fairly recent, it is possible to extract it and use it. I mean, this data has been available for quite a long time. I think it's maybe not used as much as it could. What you have to bear in mind with this data, I mean, I started in industry 12 years ago, and it's not a huge amount of time, but I've seen some evolution during that time. And for example, the share of optical sorters as part of the MRF process has really evolved, and it has increased. So we have now more data available from optical sorters, and we think, okay, that's great, that's very important. Now, what we have to bear in mind is that the data from optical sorters is the vision happens as the material goes into the machine. So that's what we analyze. We don't actually know for a fact the sorting that is done. We know obviously what the machine is going to try to do. So we had, if we want to build a good digital twin and have all the data we need, we really needed something to complement data from optical sorters. And then
go on, sorry, Luke, carry on.
And then AI vision technologies is the obvious choice there. I think it's interesting on many levels. I think the fact that it's a different way of producing the data using pardon me, pictures. I think that's interesting because for example, it's possible to do like a distinction between food grade and non-food grade for some plastics for PP or PE, and that's something that is a challenge with near infrared technology. And there is also the case that for me, AI vision system, it's a technology that is really accessible and flexible. I think it's easy to install into an existing plant. So we could go, and if we look at, if we want to monitor certain outputs, we can do that. If we want to monitor maybe a recirculation, the residue, we can go in with these boxes and just install them pretty much anywhere in the plant. I think there are some limitations in the sense that, plants from a few years ago, they haven't been built with this technology in mind. So you still have this thing where tools like that, like the infeed of the plant, you tend to have, conveyors that are like packed with material, multiple layers. So in an ideal world, we would want to put maybe more AI systems toward like the start of the process. But certainly, I think without AI vision technology, for us, the concept of the digital twin wasn't really quite working. So that's why we turned to this technology, really.
Brilliant. And I'm old enough to remember the excitement of having vision systems and, sorry about the noise, and optical sorting being adopted in MRFs in the late 90s. And that was a revolution in MRF technology. And Steve, I think we're on the cusp of a new revolution in MRF technologies. Luke's just made reference to the fact that actually we have got an aging infrastructure in many cases. Picking up one of the questions that's sort of been identified, but I think would be really useful to address at this point is, how easy is it to retrofit an existing MRF with an AI system? Is it dependent on the existing MRF capability, its age, for example, or is it actually it's pretty okay?
Yes, good question, David. It's these plants, everyone is different. That's the first challenge, and of course, built in for slightly different materials, and have been added and changed over the years. But the good thing about our tech is that it is very much a plug and play system, and can be dropped into a plant, at a single phase power within a sort of 20 minutes, literally. But the challenge is always about visibility of materials, and we have the ability to work with very high speed belts and very wide belts, and I think this is a key part of the future. The same way that optical sorters have brought in accelerator belts that are wide and fast, for that same reason that they can see the material. And I think the future, particularly on in-feed lines that Luke just mentioned, a wider, faster belt is always going to give them much accurate data. Of course, we can use AI to ascertain things quite well without looking at every item, but it's better the more we see, the more accurate the data. So it's all doable, and even through COVID, we installed units remotely in a very timely fashion, and so it's very much a product that can be dropped in. Of course, it would be great to design them into new plants. Really get to grips with the design phase, which is, of course, how we want to take it. And I mentioned all these stakeholders coming together. So that's a very critical part of it. But retrofitting, upgrades, it's all doable, as we've been doing for years with all the different technologies as they come along.
Okay. And a couple of questions that I'm going to pick up from the QA. And those of you that are putting questions into the Q&A, please carry on. I'm dipping into them based on how relevant they are to the current conversation. So really interesting one, probably for Connor and for Steve. You're currently using Greyparrot for quality assurance and quality control to measure performance and losses. Are you planning to move this into sorting situation in addition to the near infrareds, or just really as a quality control? And equally, if you don't want to answer that, that is absolutely fine.
I think from our perspective, the information that comes out will certainly drive what we do with the optics in the future. If those things can speak natively to each other and kind of self-correct, that would be a dream scenario. But even the fact that we're able to flag something up from one system, we always have a computer operator, we always have a plant manager. The call is ultimately theirs about how they treat the material. So this is about it, giving them the data to make the decision, rather than maybe just making the decision for them automatically.
Brilliant. Steve, from your perspective, how relevant is that as well?
Yeah, I think as Luke and Connor have alluded to, the bigger picture is quite critical. You know, the actual optical unit itself is quite an insular measurement, and to look at it before and after, where we can do in terms of recirculation and residue lines and inputs, we can analyze the bigger picture. Of course, you know, going forward, I mentioned earlier in the presentation, we have APIs, and these APIs can connect with any hardware. So I think you know, we could do it with robots. We've done it with robots. So, you know, essentially we can work with any of the optical sorting companies to try and give better data and better analysis going forward there too.
And I think you mentioned the robotic word. Essentially what we're talking about today is the AI system to be able to identify data to enable optimizing of the system, not for separation, but that interlink between automated identification and then robotic separation is also something that is in the mix, isn't it, Steve?
Yeah, very much so. You know, on this, again, referring to that slide, with the OEMs, I mean, the API can be, it's a, you know, potentially it's not complicated, but there's a lot of potential in all the different parts of the process. And you know, it could be with a baler, it could be with a shredder, it could be in the wash plant side of plastics. You know, there's all sorts of integration that can assist other great technologies in a way that we've never seen before. You know, it's incredible, really.
And that leads to a really interesting question, which is in many cases the nub of the challenge. Many of the MRFs, and Connor, you've got a relatively new MRF. I would be hoping that you're getting a high efficiency in terms of material capture anyway. I think this question gets asked a lot around the relative value of AI. In what percentage of efficiency improvements might you be able to expect from the AI investments? And I'll open that to everybody, actually.
For me, it's maybe a little bit too early to answer, but certainly in principle, the idea is that first you need to understand what's going on in the process, being able to measure. And if we understand, when outputs drop in quality, and then we can look at the process, other elements of the process, and try to go to the root cause of that. Try to understand, okay, is this when this NIR is, overutilized, this is what happened. And then you can start, at least, well, as a first step, start notifying the operator that this is happening. In the longer term, you can probably anticipate issues before they actually arise. If you notice that you have these different elements happening in your plant and you know what that leads to, then you can say, okay, we need to correct something. There's going to be an imbalance in the process, which we need to address. So this is certainly what we're hoping to do. So first is about, really just, understanding when the quality drops. And then the second stage is going to be really try to bring in a correction course into the equation.
Okay. And Steve, from your perspective, the value to the MRF operator for bringing in AI, essentially, there's a reducing contamination, improving knowledge element here, isn't there?
Yeah, I think the interesting thing, I mean, Luke mentioned it earlier, there's this big black hole that we've seen. We know what's at the front and what's at the back, but often in the middle we're guessing. And we have conversations in plants where you go into a plant and the guys will say, yeah, the guy on the grab at the front there, he's our eyes and ears. And without him, we couldn't process properly because he knows what to put into the in-feed and mix it all up. Well, and then the same, other parts of the plant, they'll sit over a rail and look at the quality and go, that looks about right, or and this is what you've been relying on. Some guys who know what they're doing, but it's a bit of an old-fashioned way of doing things, and this really just allows you to look at it and action those things maybe ahead of time, and not necessarily always afterwards, and get the optimization just and the balance right, and without having to guess and assume.
So yeah, an overall system improvement. And so essentially this technology allows you to identify the actual problems and intervene with a level of knowledge that wouldn't have previously been available.
Yeah, I mean, I mentioned one of our new dashboards coming out, the alerts feature, which, it'll be a big visual thing on a big screen, in the same way that a plant builder screen is in the cabin, the control cabin, and it'll be with warning signs and signals that, and the thresholds you can set are on multiple materials. So you can set 3 or 4 different materials on one line, and if those materials change within the parameters that you've set, it'll tell you there and then live. And that kind of information is invaluable.
Yeah, so continuous monitoring, which is brilliant. And
yeah.
Connor, from your perspective as an operator, what is it doing to improve your performance as a MRF operator?
Having the data and having figures that you can trust allow you to build business cases for doing things. So maybe in 2004, for example, we would have said the residual line is the residual line. That's just stuff we can't recycle. So what this would allow us to do then is to analyze that residual line and say, right, we would love to take aluminium cans out of that, but to build a business case, you need to know how many there are, how often it happens, when it happens. So without putting somebody on the line 24/7, there's no way you could do that. That's where these systems fill that gap to say, okay, we have a threshold here of 1% aluminium cans. If the residual goes above that, tell the plant operator, tell the plant manager, guys, we're throwing away value here.
And absolutely, and I think that we are throwing away value, we're throwing away resources is one of the main reasons why this technology can actually be very suitable for the huge volume of recycling that we manage, not just in the UK, but across the world. And I think that's one of the things. And there's a couple of questions coming through on the QA, and we want to address this anyway. And either to completely knock it out or to look at how relevant it is as an issue, the householder. In the sector, we know that the householder is in many cases responsible for contamination, cleaning out of different materials, etc., etc. A couple of questions on that. Firstly, how does the AI system, does it get compromised by, let's say, food contamination on different materials? And also, does this mean the householder can be less rigorous about how they recycle, or more rigorous, or just carry on doing the same? Steve, I might start with you on that one.
Yeah, interesting question. I mean, I've been to some lovely recycling plants where the material is clean and dry, coming from householders' bins, nice and not, coming out of container vehicles that haven't been compacted too much, and it's a lovely, lovely material, easy to do everything with, separate in any way you want, and of course visually you see as well. But a lot of our customers, they're moving materials about and the baling materials, so we have to be able to see these materials in a more compromised manner, crushed, bent, folded, dirty, covered in all sorts, and it makes no difference to us. We can do the same level of recognition there as we can with a complete whole bottle or cardboard box.
Brilliant. And just building on from that, and I'll let Luke and Connor come on to that question as well. One of the audience has asked a question around live data, and we've been talking about experience and the vision systems. Steve, you gave a little video at the beginning of what the actual image looks like on the belt. Could you just extrapolate that a little bit more and tell people, we saw a video essentially of what the picking line looks like and then how the system identifies. Can you just delve into that a little bit more, just to give the audience a bit more understanding of how it actually works on the day-to-day and actually in practice?
So you're relating to what, the AI side of it, or just the how it actually works, or
more about how it works?
Yeah, so I mean, what we do, I mean, if we look at Connor's application, we've got a unit in the quality control cabin in this particular application. and the unit is sitting on the belt before the pickers, and the material comes out of the plant and is presented under the camera, and we're actually analysing that material live, and then on that basis we can show them what's going on there and then, and of course then we can create all sorts of reports with historical data, and this is where they're able to then compare 1 hour or 1 week or 1 month to another. And then in the second part of this application, these particular task is to pick the materials, and the second camera is then showing the efficiency of what they're doing, and then the final quality. And that material then has a whole host of other, the commercial teams will then be able to see that data. And to take that one step further on this particular application, it goes through to the baler, and we're able now to put what we call a digital purity stamp into the RFID tagging system that a lot of these baler manufacturers are now using. Another thing on your list of new technologies along with blockchain, and actually track wherever the bales go, you can track the quality as well. So that's all doable on this one line with 2 cameras. And just to add another application there, on the final quality now, on continuous flows, the Environment Agency have said, this potentially can be used for the code of practice returns data for the UK, as well as spot sampling or as well. So it's quite interesting developments on that side of it. So there's lots of possibilities just for the camera analysis in one particular part of the plant.
And that's really interesting. There's a question from slightly earlier on, which fits in really nicely with that, which is one of the unintended consequences, the fact that you've now got the ability to be very accurate about what the outflow is, meaning that actually if a customer requires a 95% quality percentage, and the system is you're getting a bale with 94%, for example, because you've got the accuracy, whereas visually previously an operator might have just gone, yeah, that looks about 95%. Is there an unintended consequence that you might actually be positioning some of your bales in such a way that they're not as valuable as they might have been if we hadn't been using AI? That's probably Steve and then Connor.
Well, it's interesting. I mean, the thing about AI, it uncovers a lot of good things and bad things about processes. And at the end of the day, we've all got to understand that, the best practice is always the way forward, and understanding what's going on. And I think you just read the news, environmental news about material that gets shipped, the spot samples are taken, and there's material that shouldn't be there, and the whole stuff is returned and with massive fines. So this would take away any issues on exporting of materials, for sure. Yeah.
Connor, from your perspective, how does the accuracy help or not help?
It's actually a massive help for us because, again, we're trading for so long. We trade on our name, on our brand, and if we were sending in customers, like the operations guys in here are so efficient and so professional that we can always stand over our quality stamps. And if we couldn't, our BD guys wouldn't be able to sell the stuff. So our BD team do an incredible job as well about end market research and stuff like that. And customers always are very open to buying from us because our quality is consistent. If we were selling something at 95 and it turned out to be 84 regularly, we wouldn't have a customer very long.
Yeah.
So this transparency is actually something we would welcome and embrace.
Brilliant. Okay.
Just to add to that, just one thing as well. Having this guaranteed digital stamp, it would eradicate this bale dressing thing that goes on. You've got a lot of people standing around making bales look pretty from the outside, well, you won't need to do that. So it would be a massive labor saving there for sure.
Yeah, that takes me back to when we ended up having cars being recycled as scrap metal being filled with rocks to get the volume up. So yeah, I think that accuracy is really, really important.
Just on that point as well, sorry, David.
Yeah, go for it.
From the customer perspective, because we could have the information about all our bales, there's a risk on the customer side. If they sampled one bale and that bale ended up poor quality, they could extrapolate that to say the 100 that you sent us were poor, or we could say, well, actually, no, here's the evidence of the plant as your bales were being made. Here's the material going into the baler, you know.
And absolutely. And Luke, from your perspective, how does this as a system approach start to inform the work that you're doing? Because fundamentally, if we're looking at this as a system, the end goal is to try and get as good quality a bale of material to the customer as possible.
Yes, that's right. And the idea first is try to understand when the plant is not hitting the right quality, it's trying to go back in the process and look where the issue might be. Is it overutilization of certain equipment? Is it due to certain material composition going into the process? But the first step is to actually understand, trying to identify the root cause, and then trying to find, and then I said, like, the next thing is really actually alerting when we know we are in this situation where we know things are going to go bad, or things are already going bad because we're monitoring the output. Obviously, the earlier as a MRF operator, the better, because you can have, speaking to a MRF operator, they told us we had an issue with an optical sorter for a few weeks, actually a few months, and they didn't realize it because you didn't really have this data to back, this understanding. I think, and Steve mentioned earlier, there is a lot still in our industry and MRFs of, like, just people looking at, conveyors. How is it, how is it going? Is it looking good? Because there wasn't really any better alternative. But this is, like, just looking is extremely hard. I think we want to have the data in the process to back basically whether it's something to do with, like, the quality of the outputs in the end, or if you're trying to optimize, your plant, at the moment, if you change the settings to a machine, you're going to look at the conveyors. Okay, is it better? Is it worth? Extremely difficult. If we can say, this is what happens to your outputs, this is what happens to other sorting equipment in your system when you make that change, then you can actually take an informed decision and say, this is a change that is worth making.
Okay, brilliant. Thank you. Right, I'm going to take the next couple of minutes to address a few relatively simple questions, which should be really, hopefully, simple to answer quickly. Steve and Connor, there's a question around the full-time tech team to manage the IT element. Steve, as Greyparrot, you bring the experience to the process. On an operational basis, how large is the team on both sides, and is it large at all?
Our operational team?
Yeah, so if for example, we take Regen as an example, what sort of resource outside of setup would be required to run this on a day-to-day basis, and the same for Connor?
Yeah, I mean, look, we're a team of, as I mentioned earlier, around 35 people. And most of that is, there's a couple of people on sales. That's really all. And most of it is behind the scenes. We have an operational team that take the installation and the onboarding process through, the training. Then we have a big customer support team that basically will work with the customer on an ongoing basis, not just during a sales process, but right through to work with them in terms of, what do you need from this dashboard? What do you want the data to do? How do you want to do it? And this, combined with our experience of what we know, how the plant works and what we want from the plant, we work together on that. And then behind the scenes, we've got our scientists, data scientists, and the people that build our own dashboards, and the people who build our own products as well. So there's a high skill set in Greyparrot there, across various parts of the components that we need. And but hopefully, the customer support side is critical part as we build a product to adapt for this new technology. And we work together with guys like Regen and SortFlow. Okay.
And Connor, on your side, is this an existing member of staff that's interpreting the data that's provided, or is this new staff, and is it a new team?
Yeah, existing members of staff. So IT projects in general, we kind of have a mindset where we act almost like Sherpas for people. So we would be enabling the operations department to read these things, to analyze these things, so that then they take it forward. So we would be dedicating resources to the onboarding, to the setup, to the familiarization, to the design. But then ultimately, our ops team and our BD team are the ones that are going to drive the value out of it. So having them lead on it with us supporting is, we find, gets better results than maybe an IT-led specific project that we then hand over to somebody in ops. So fairly lightweight on our resources, a burst of say 3 months intensity on a IT member, but that's more just about familiarization and accountability and embedding the habits and the routines. After that, ops are, fine to operate all this on their own.
Okay, a couple of very specific, probably yes or no's for you, Steve. Is barcode information collected through AI? And I'm going to guess that that's only if it's visible, if the barcode's available in front of the camera.
Yes, and that's another discussion.
Yeah. Good. Okay. The other one was, you mentioned in your presentation, Steve, that you're able to capture mass data. Could you just extrapolate a little bit more on that?
Yeah, sure. I mean, so this is about the accuracy of the AI. Now, I mentioned the wider, faster belts before, getting material spread. And, we need to be able to see 50% of every item. If we can do 50% of every item, we can count every item. And the work we've done with Regen on difficult things like paper lines, we've actually able to give them, high accuracies of conversion from item count to weight with more difficult items like paper, where you've got 2D materials, different shapes and sizes. But we have algorithms to work with that on size and mass, and then we do a lot of internal stuff to build that together to get these accuracies. So we've proven to Regen of accuracy levels of 97% plus on large volumes of fiber streams on continuous flow, not just here and now, but continuous, big tonnages. And container line material, of course, is even easier for us because it's easier to see and measure. So, our container line accuracies are in excess, and we can even do it with plastic films and flexibles as well. But as you can imagine, a little bit less there, but it's all doable using AI and a lot of work we've been doing over the past 4 years on this.
Brilliant. Okay. Thank you, everybody, for your Q&A. There's a few still in the chat box, which we'll either type an answer to or come back to afterwards. I just want to draw a bit of an ending to this and just ask the three panelists a couple of big questions, but in a very short answer, please. So firstly, what do you think the potential scale up of AI in the MRF context is, and what are some of the blockers? And I think, Luke, I'll start with you, then come to Connor, and then finally Steve.
So yeah, I think there is the side to AI where it's applied to sorting technology, and this is still there are a lot of developments being made. We've only seen the start of it. I think there's been a lot of talks about robots, but optical sorters. We've embarked AI are coming. And there is also then obviously the data side, and the data side of AI is there again, same thing. There's a lot more that could be done. Obviously, we are building what I believe is the first digital twin for recycling plants. So we are doing it for existing plants, with plants that haven't necessarily been built with that in mind, and it is possible. But I really hope that as the industry goes forward, this is something that is on the back of everybody's mind, really. So yeah, I think on both sides, on the sorting part and on the data side, there's going to be huge developments in the coming years.
Brilliant. And Connor, from your perspective, the future and blockers, if there are any.
Well, the future is that as labour and people and skills become more and more scarce, that is what drives the search for things like AI to fill those gaps. So I think that demand is going to take care of itself. In terms of the blockers, I would say we have to do quite a bit of work in change management and disrupting, particularly with operations or people like that who are really skilled at their jobs and maybe have workflows and rhythms that they've built over 15 years. To introduce something to those guys, it has to be valuable. It has to be no worse than what they currently do. It has to be seamless. It has to be robust. It has to be all these things. So those are challenges that are definitely there to be overcome. But yeah, that initial skepticism and resistance, we also find that once we get past that the ops guys and BD guys and finance and everybody in here, they start to think of things we never thought of. And the best people to think of this stuff are actually the plant managers and the plant operators. So on one side, you do have a blocker, but once you get past that blocker, it'll explode.
Yeah, I think that's the one really good thing about this sector. We had a similar thing when we were doing pothole spotter using AI cameras for identifying potholes, and there was a huge skepticism as to why you have a camera on the front of a bin lorry. As soon as they bought into it, it was right, let's go and promote it, let's go and do what we can. And that is where a lot of the knowledge is. Steve, very quickly, future from your perspective and blockers, and then I've got one final question for the three of you.
Yeah, blockers, I think it's like with all things new, it's engaging and trying it and getting stuck into it. I remember starting in optical sorting 17 years ago or so, and everybody said, "Oh, I'm not buying that, it's too expensive." And now, with everybody working together, all different stakeholders, it's become an integral part of every single plant. And this is where we are going to, be with this technology. But everybody's got to come together and not be scared of it, and try it out and learn from it and help each other.
Okay, and then finally, in 20 seconds each, single piece of advice for how people can get on board with AI in their role. Luke, Connor, Steve, in that order.
Right. Well, I think, as Steve just said, I think people shouldn't be scared to try it, to experiment with it. The barrier of entry is not that high. You can really implement it, fairly easily. And they are we're trying to build a really good AI-driven solution. So yeah, easy to try to experiment with. So that would be my advice to MRF operators out there.
Brilliant. Connor, from your perspective?
Very simply, I think that if we adopt the mindset that we're driving instructors, not chauffeurs.
Like that a lot. And Steve, from your perspective?
Look, despite what you may have heard in the news recently about AI, I do think here getting on board here with this stuff is going to change MRF into a real processing industry, like many other industrial processes, and really bring that to the next level. Give it a go. Give it a go.
Give it a go. And I think just this is an open question. Are there opportunities for interested parties on this webinar to come and actually visit MRFs that are using AI? Connor, you're nodding. I'll go with you nodding.
Yes, absolutely. We're very open people. Steve will tell you that.
Brilliant. So there we are, everyone. We've got an open invite to go and see Steve, to go and see Connor. Steve, from your perspective, are there other applications that are available for people to look at as well from a different geographical perspective?
Yeah, I mean, the thing about our technology is easier to present, in this format. It's a box with data. It's not like you're seeing a shredder or a baler or an optical sorter where there's actually something to look at. You're looking at a grey box, but it's interesting to see a site because you can understand how the process works better and where the cameras are positioned and what we're trying to do. So that, is a big, that's doable, of course. But the interesting thing is in the data and the dashboards. Brilliant.
Okay. Thank you to all three of you for being brilliant presenters and engaging in lots and lots of different questions. Hopefully for the audience, this has been a really useful and eye-opening discussion around AI. and how it links into the waste management sector of the future, or should I say resource management sector of the future. So that's our hour. Thank you to everybody. Thank you to RWM for hosting, and to Greyparrot, SortFlow and Regen. And from my perspective as Circular Economy Institute, this AI technology is very much the future that will facilitate moving towards a circular economy. So thank you all very much, and enjoy the rest of your day.